Methodical, patient tone. The modern elevator bank functions as a high-efficiency, localized transit system. Our objective is the execution of a secure, efficient, vertical transfer from your current floor to a specific destination. When systemic delays occur, they are rarely the result of mechanical failure. They stem from user input errors at the control interfaces. Before initiating the system, you must satisfy two strict prerequisites. You must know your exact current floor, and you must know the precise floor you need to reach. Operating an elevator is an exercise in strict input-output logic. Mastering the interface provides the specific data needed to complete a vertical transit cycle. Step 1 takes place in the exterior waiting hallway. Locate the external wall interface. This is known as the hall station. The directional inputs operate on simple binary logic. You only need to determine if your destination lies above your current position or below it. This diagram illustrates a primary user error. Users frequently press a direction based on where the car is currently located, pressing down because the car is traveling down, but you must press the button matching your intended upward vector. Once you press the correct button, look for the system's immediate feedback. A distinct halo of light will illuminate around your selection, confirming your input is logged. Next, monitor the secondary arrival indicator. An overhead lantern will illuminate, and an audible chime will sound to confirm the car has arrived at your floor. The hall call signals the building's central routing algorithm, integrating your request into the flow of vertical traffic. The kinetic cycle begins with mechanical power. Heavy, featureless steel elevator doors smoothly and autonomously part, revealing an empty cabin. Boarding requires specific sequencing. Establish a clear vector by waiting for all departing mass to exit the cabin first. Never breach the closing sequence. Thrusting an arm or a leg into the frame to block moving doors introduces severe physical risk. Instead, the doorway contains an invisible sensor matrix. Breaking this plane with your body naturally triggers the system's autonomous retraction safety protocol. Before making the physical action to cross the entry plane, pause, visually check the gap between the building floor and the car, then step confidently across. A successful boarding phase relies entirely on synchronizing your human movement to the machine's unyielding operational timing. Now enclosed in the cabin environment, direct your immediate focus to the system's central nervous system, the car operating panel, or COP. The destination array features a numerical, grid-based layout. Locate your correct target node and press it firmly. Reiterate the check from the hallway. Look for the visual feedback loop. The destination button will illuminate to confirm your target is locked. This diagram deconstructs the visual logic separating the manual door overwrite symbols. Triangles facing away from the center line illustrate expansion, commanding the doors to open. The triangles facing inward demonstrate collision, commanding the doors to close. Mastering the COP gives you direct control over the machine's final trajectory. As the kinetic phase of travel begins, shift your attention upward to monitor the shifting spatial data. The floor indicator array tracks the cabin's real-time vertical progression. Watch the numbers change as you pass each level. A terminal audible chime, and mechanical door separation. Execute a final visual verification process. Check that the designated floor number posted outside the doors matches your target arrival environment before stepping forward. Safely crossing the threshold at your exact required destination proves the underlying algorithm is flawless when fed the correct human inputs. You are safely present in your new target environment. The operation is an absolute success. You initiated the external vector summons, routed the internal command execution, and finalized your disembarkation. The core logic you learned in this specific sequence maps universally to virtually every standard vertical transit system operating globally. Operating an elevator relies entirely on a sequence of logical, predictable steps. Execute them correctly, and you ensure absolute control over any vertical journey.